Flack math! Give me some math and I'll give you some flack. Flack math!
Okay, so we're going to multiply powers of 10, which is really easy.
What?
Multiply powers of 10. The real easy, quick explanation is add the exponents, right? For example, what's 10 to the third times 10 to the fourth? You guys know?
10.
Kiara?
10 to the 12?
Nope.
10 to the 7.
10 to the seventh. Now here's what's happening. 10 to the third means 10 times 10 times 10, right? So that's 10 times 10 times 10. And then times
Wow.
10 to the fourth. That just means 10 times 10 times 10 times 10, right? How many 10s are you multiplying?
7.
So it's weird, but when you multiply exponential expressions, you end up adding something. Well, you find that weird? Well, it's not really an addition problem, but you're just, remember, adding is just fast counting. So you're just counting how many times you're multiplying 10. Okay? Can you guys remember that?
Yeah.
All right. So here's what we're going to do. We're going to squish it all together. I'm going to multiply two numbers that are already in scientific notation. 1.2 times 10 to the fifth times 3 times 10 to the seventh. Okay? Well, multiplication, remember there's a rule that says it doesn't matter what order you multiply in, right? So I can multiply these two things first. What's 1.2 times 3? 3.6. And then, of course, we just learned how to multiply 10 to the fifth times 10 to the seventh is 10 to the 12th. You're done. Okay? So if you start in scientific notation, end in scientific notation. Is this in scientific notation?
Yes.
Yes, because it's a number. There's only one non-zero digit before the decimal, and you got a power of 10. You're good. That's it. All right. Let's try another one. This time, we are not going to end in scientific notation, and we have to put the answer in scientific notation. So here's example 2. 4 times 10 to the 6th times 3 times 10 to the 5th. Okay, so you can probably do the first part in your head. So what's the first part? What do you get when you do the first part, Grace?
So you do 4 times 3 is
Okay.
7.
Ooh, now you're getting it.
12. Sorry.
Yeah, there you go.
12. And then 6 was 5. So 11.
Yeah, so now see how that addition kind of messes with your head when you go back to normal multiplication. Okay, so that's right so far, but is that in scientific notation? No. What makes it not in scientific notation? The decimal needs to be there. Well, if I put the decimal there, I have to multiply by another power of 10. So how do you write 12 as a power of 10? 1.2 times what?
10.
Yeah, 10 or 10 to the first.
Oh.
Times 10 to the 11th, which is 1.2 times 10 to the 1 plus 11 is 12.
Wow, really?
Okay. Now, some of you, not me, because I have a little bit of dyslexia and dysgraphia. So some of you will be able to do this whole thing and get to right here right away. Because you'll see this 12 times 10 to the 11th. Oh, so this needs another power of 10, so that's 10 to the 12th. And I think I could handle that pretty easily, but I'm going to doubt myself because it's hard for me to think backwards and forwards. But sometimes it's easier for me to think backwards than normal people. I'm not a normal person, okay? Which is good. So sometimes things are easier for me than others, but some things like this sometimes are more difficult, okay? But that's okay. You adjust and you figure it out. Let's do example 3. See if you guys can do this on your own. And how about we do, this one is worth a free problem set. So 2 times 10 to the negative 5th.
Wait, a free problem set?
Yep, if you get the first one to get this right, you got it. Times 3 times 10 to the negative 7th. So write it down on paper if you got it. So 2 times 10 to the negative fifth.
I got it.
So do you have it on paper? Nope, you don't. Times 10 to the negative fifth and 3 times 10 to the negative seventh.
I don't have paper.
Okay? Well,
can't
you're
do
in school, you should have paper.
Well, I don't.
Okay, that's all right. You don't need a free problem set.
Yeah, I don't. I already have 4.
Wait, does it need to be in scientific? I'm trying to go so fast because I want to get this right.
That's it.
Yeah.
Good job. Having paper. Because all of you can do this in your head, can't you? So it's just 2 times 3, which is 6, and then 10 times negative 10 to the negative fifth times 10 to the negative seventh. Add 2 negatives together. They become one big negative army. So negative 12. Right? Is that what you guys got in your head?
Yeah.
All right. Good job. Now, so this is just what it means. We're gonna do more of these because I want to give more free problem sets. Okay, ready for one more? All right. Now, if you're the first one to get this final answer in scientific notation, then you get a free problem set. Okay. So Grace, I'm giving you that. And if you just get it, and you're not the first one to get it, I'll still give you a Flack attack. Okay. So you'll get a point. So who's got 49? Avery's got 149. So if you just do this right and show me, then you get one more for 150. So Grace, you got your 2 becomes a 7. Good job. Ready? Here's example 4. And I'm going to talk and say this so just in case I'm blocking your vision. So 5 times 10 to the third all times 7 times 10 to the negative 8th.
Negative 8.
Okay, well, that's the right power of 10. Oh, sorry. So far, that's right, but that's not the right answer. So you got a wrong sign there.
Maybe. What's that? Wait,
All right, she had a hand up first.
wait,
Good
did I get it right?
All right, so Avery got the
I'm so
Flack
confused.
attack, and that's not quite there. So 5 times 7. Remember, you're in multiplication mode.
Wait, yeah.
It was 35 times that.
Oh,
So
5
now
times
you gotta
7.
Change
Oh,
it.
multiplication. Wait, I put 3.5.
That's right so far. Now put it in scientific notation.
Oh,
Not
Wait, Mr.
quite.
Flack. Oh, I totally forgot that. Done.
No, so you just moved the decimal and didn't change the exponent. That's right. Good job. So you got a Flack attack. Not quite. I think you multiplied instead of added the exponent. There it is.
I did the opposite.
That's right. So far, without the decimal, that would be right. So now you just have to put it in scientific notation. That's right, in standard notation. That's right. So now you have to write it as the first non-zero digit has to be before the decimal. Anyone else?
Me? I got it.
Nope.
Oh. Is it?
That's right so far.
Wait, 10.
Let's see how that's not in scientific notation.
Superpower.
So scientific notation is like what all those started with. So 1.2 times 10. So there can only be one number to the left of the decimal. There it is.
There we go. Okay.
Nope. What'd you get? Yep. You figure it out the rest of the way? Okay. Anybody else?
It's 3.5. I just now realized that.
Yeah. Did you get a final answer?
Yes.
Whoa. All right. So Avery, you didn't get 1 point. You got 5 points.
Yay.
So now you're at an uneven 54. So you have to get 1 more point.
Sorry.
All right. So who else got it?
I did.
Grady got it. And Hunter got it. Who else got it? Did you get it?
Yes.
What's your final answer?
3.5 times 10 to the negative 4.
Good job. You got it. And Hunter got it. Who else got it? Grace, you got it? Yeah, you got it.
I got
Oh,
it
wait.
at the end too.
Okay, good job. Okay, so let's just do it real quick one more time and then we'll move on to the next lesson. So 5 times 7 is 35. I think most of you got this far. So you got everyone understand this part right here? Because all you're doing is multiplying 5 times 7. And a couple of you did add again because you're in this addition mode because you're adding the exponents. But 10 to the third times 10 to the negative 8, when you add the 3 plus negative 8, remember they're unlike signs, so they fight. And so you end up with negative 5. A lot of you got here, okay? So what do we do next? Elijah, if you can walk me through this, I'll give you a Flack attack. Because you got this far. What do you do next? Okay, that's all right. Anyone who didn't get a Flack attack want to explain it? Anybody? Well, you already got a Flack attack. Okay, well, the problem is this has to be written with the decimal there, 3.5 times something, right? So I'm going to put this part in scientific notation. How do you write 35 in scientific notation? Which seems silly, but we do it. So how do you do it, Adeline?
Add a decimal after the 3.
So 3.5. And what do you have to multiply to get to that? Hunter, what do you have to multiply by? This one?
I don't know.
Adeline?
A power of 10.
Just
10.
1 power of 10. So times 10 to the first. So you have to move it 1 to the right to get back to 35. So that's really what you're adding to this exponent. So all times 10 to the negative 5th. And when you add 1 plus negative 5, you get 3.5 times 10 to the negative 4th. So there's your final answer. Okay? Now, if you show your work, guys, and you get this far, awesome. Half credit because you did this part right. And that's the hardest part. Well, maybe not. Maybe that's the easy part. The hardest part is writing it in scientific notation. Now, why didn't we have to do it here?
Because
6 in
Because
scientific notation would be
it's
6.
already in scientific notation. There's only one number to the left of that decimal. When you don't see a decimal, it's on the end. So this is like 6.0 times 10 to the negative 12th. So this, you were done. You didn't have to convert your answer. But sometimes when you multiply, you get a number that falls outside of that in between 1 and 10 number. So the number's got to be in between 1 and 10 for it to be in scientific notation. Okay. Does that feel okay?
yes.
You guys think you can tackle those?
Yes.
All right. One more lesson today. This is good. So here's the deal. Back maybe 15, 20 years ago, there was no class called Math 8-7. It went from Math 7-6 to Algebra 1/2, which is our pre-algebra, to algebra. But then they realized that a lot of people really struggled with algebra because they were not prepped enough for algebra with just that pre-algebra class. So they came out with Math 8-7. And so Math 8-7 is like the biggest Saxon book that you'll have. Okay? And so it just wants to make sure you understand all these concepts before you start thinking algebraically. Okay? So some of you will go right from this class to algebra. Some of you just need another year of practice, which is the normal course of action. But if you guys are like bored out of your mind and you do this stuff in your sleep, then we should talk and you should just go right to algebra after this. Okay? But this lesson is going to talk about the algebra part of math. Now, here's the deal. Math is algebra. So when you think of math, algebra is the all-encompassing term. Okay? So we're going to talk about just some terms that you'll see in algebra. So we're going to talk about algebraic terms. Okay? So these are parts of an equation or expression and things like that. So a monomial. A monomial is a single term. So mono means one. So a term. Well, what is a term? A term is something that's being added or subtracted. Okay. So if I had first of all, let's put all the definitions up here first. What do you think a binomial is, and what do you think a trinomial is?
Ooh, I know what a trinomial is, I think. And I know what binomial is too.
Hunter, what's a binomial?
2 terms.
2 terms. Bicycle. 2 terms. What is trinomial? Addie?
3 terms.
3. Tricycle. 3 terms. Okay. So for example, x squared plus 3x plus 2. See how there's 3 things being added or subtracted. So this is a trinomial. Like I could do a binomial that maybe it would be like A plus B. That's a binomial. There's 2 things being added. Okay, you could do 73x to the 4th minus 9x squared. That is a binomial. There's only 2 terms on there. Even though they look funny, they have exponents, there's multiplication happening, but there's only 2 things being subtracted. A monomial could be like this, like 53a, b, c, d to the 4th. See how there's nothing being added or subtracted. It's all being multiplied, or there's powers, which is really just d, right? 4d's being multiplied. So it's just a product of stuff all squished together, but nothing's being added or subtracted. That's a monomial. Another monomial could be 7. Okay? That's another monomial. There's nothing being added or subtracted from 7. So that's a monomial. Okay? Questions so far? So it's hard to describe a term, to define a term. But the best way I know how is things that are being added or subtracted. So if you don't see any addition signs or subtraction signs, you can see negative signs. Like, look, negative 5x. That's just one term. Technically, that could be a subtraction sign, but it's not being subtracted from anything. So it's just one term. Okay? That's a negative 5x, not minus 5x. Now, if I put a 0 in front of there and I said 0 minus 5x, that could be a binomial, I guess. But you can do that. 0 minus 5x is just negative 5x. Okay? So each term contains a signed number. Okay? So this is important to know. Each term contains a signed number. Now, what happens if you don't see a number? Well, let's give an example. So 3x, the signed number there is positive 3, right? That's positive 3. Let's try another one. What about in this term? What signed number do you see there? What happens if there's no number? What number is really there?
0.
What number? Not 0. So if it's 0x, it would disappear.
It would be 1.
1x. So remember, I can sit on a stool or I can sit on one stool. Either way, I'm sitting on this stool. Okay? So or 1, same thing. In other languages, there's no difference. You could say 1 or like Spanish. People used to make fun of us when we used to say uno momento. Now you don't say uno momento, you just say un momento. So un and uno, still mean the same thing. And one mean the same thing in Spanish. Okay. But so it's kind of silly to say one moment when you can just say a moment. Wait a moment. Okay. So that's 3. So the number that's there is just a positive 1, right? Okay. What about this? What about this? What number is in front of that variable? Adeline?
-1.
Negative 1. So that has a sign and it's negative 1. So if you don't see a number, it's 1. And if there's a negative sign in front of it, it's negative 1. Okay? These numbers are called coefficients. These are what the variable is being multiplied by. Okay? They're called coefficients. Now that's a fancy word. We're going to talk about that more in depth when we get to algebra. I'm not even going to write it down right now. Okay? So a constant term is constant. It's constantly the same. It doesn't change. So remember what we call these letters in algebra? What do we call these? What? So the whole thing is a term, but what's just that thing called? A variable. That's right. So variable means it's able to vary. What does vary mean? Change. So it can change. Depending on what you pick for x, it can change. So 3x could equal 6. It could equal 9. It could equal 12. It could equal 15, depending on what you pick for x, right? But a constant term will never change. So that means there's no variables in it. Okay? So not variable. So I spelled it wrong on purpose so you can see that it's not able to vary. So there's no variable terms. So for example, you have like, if you have like a bunch of terms, here's a trinomial, x squared plus 3x plus 2, like what we had up here. This is your constant term because there's no variables in it. There's no letters that would make that 2 ever change anything from being 2. So if x is 7, that would make this term 21. If x was 7, that would make this term 49. If x was 7, is that going to affect that at all? No, because it's not being multiplied by an x or divided by an x or added to an x, or it's added to an x, but that's another term. So that 2 will always be a 2. You can always count on the consistency of 2. That word is the same as constant, comes from the same thing. Yes?
Is then 7 a constant?
Yes, this is a constant. Here's another constant term. This is not a constant term.
No.
This is not a constant term. If you see a letter in there anywhere, it's not a constant. So, and so the other types of terms are called variable terms. It has a variable in it. Constant term, it doesn't have a variable in it. That's pretty easy to remember. Can you guys remember that? Okay, so that's our next definition. Variable terms. So to define it, no variable in it. Okay, and this variable term has a variable in it. It's able to vary. So for example, in this case, you've got 2 different variable terms right there because they have letters in it. Okay, so some variable terms can also be combined, okay? So these can be combined if they are the same. So can be combined only if they are the same kind. So there's a saying in math, it sounds very segregated, but we said this when we dealt with fractions, but also when you deal with variables, to compare or combine, like add or subtract, you must be the same kind. Doesn't that sound a little segregated? Probably can't say that anymore these days. Okay, compare or combine, you must be the same kind. but I get what it means. So you can only add 1/4 to 3/4 because they have the same denominator. You can only compare 1/4 to 3/4 if they're the same denominator. What's bigger, 5/7 or 13/15? You can probably do that in your head. What's bigger, 5/7 or 13/16? Well, you can't do that unless you have the same denominator. So that's what it means to compare or combine. You must be the same kind. Well, same thing here. This x squared cannot combine to a 4x squared. Let me show you what's happening. Okay, we're going to try some examples here. Let's try 3x plus 2x. What do you think 3x plus 2x equals? 5x. So what's 3x mean? What's 3 times x mean? That means x plus x plus x, right? That's what it means to multiply, right? So 3 times 5 would mean 5 plus 5 plus 5, right? So 3 times x would be x plus x plus x. Plus 2x, well, that's just x plus x. So how many x's are being added total? 5x. So basically what's happening here is when you have variable terms that have the same variable and the same amount of variables, like x and x squared, this has 2 x's in it, this has only 1 x in it. But what's happening is you can just add the coefficients. There's 3 x's added to 2 more x's. If you replace that with apples, instead of x, you can say apples. What's 3 apples plus 2 apples? 5 apples. So this x is kind of like a label that we used to that our math teachers used to make us put in our answers, right? Or what's 3 inches plus 2 inches? 5 inches. So 3x could be anything. Elephants. 3x plus 2x is 5x. Okay? So what's 3x minus 2x? 1x, which you could, I guess you could just say x, right? Because 1x is just an x. Okay? All right, let's try another one. What about negative 3xy plus xy? Well, it doesn't matter what that variable is. Remember, it could be anything. It could be elephants. In this case, it's just xy. So what do you think your answer is? What's negative 3xy plus xy? Avery, do you know?
Negative 2xy.
Negative 2xy. Look at this. All you're doing is adding the numbers in front of them. What number do you see in front of this term? Nothing. So what number's there? 1. So you got negative 3 apples added to 1 apple. Well, that's kind of weird. I don't want to eat negative apples. That would mean me throwing up on you. And I don't want to do that. That's not safe or healthy. Right, Addie? Right? Okay. Okay, so negative 3 plus 1. Let's think of it like this. Negative $3 in your bank, which is not good. You owe somebody money. Plus $1. You took away some of your debt. So what's your debt now? Negative $2 or negative 2xy. Okay?
That's a better analogy than apples.
I know. Everyone knows negative money. Too many people know negative money. Yes.
Technically, I don't think you're allowed to have negative $3 in your bank account.
Well, yeah, that's called you're overdrawn, and then you get charged like a $25 fee. I don't know where they're going to get that fee, but you're charged a $25 fee. If you ever spend more than you have, it's called overdrawn. And then your debt's bigger because now you owe 25 more bucks. Yes, Kiara.
If you pick up the variables and money in the answer, should we put a $sign or a cent sign?
Oh yeah, if this was like, but think about it like this. See how I make you put your label again. So negative 3xy plus 1xy is negative 2 what? Negative 2xy's. Okay, think of this xy as like brown elephant. I don't know. So you have negative 3 brown elephants added to 1 brown elephant. Well, now you have 1 less of your debt, so negative 2 brown elephants.
You have a debt for an elephant.
I'm gonna stick with money, okay? Because Grady told me it's easier to understand. And he's smart.
I like brown elephants way more.
Okay, well, yeah, that's good. What if we paid people in brown elephants? We'd have really big wallets. Okay, so you cannot add these two things together. Okay, this is x times x. This is not x plus x, right? X times x does not play nicely with x, okay? So they have to have the same exponent. If they have an exponent, now you can add 3x squared plus an x squared. You can add x squareds with other x squareds. You can add x's with other x's. You can add xy's with other xy's, but you can't add an x with an x squared. All right, you just can't. If you think about replacing an x with a number, 3 squared is 9. You can't add 3 9s to 3 times to like just a 3. No, you can't do that. Okay, so we're going to do 2 examples, and then we will be done for the day. Okay, you ready? So, how about we do a first one, get it again, get a free problem set. If Avery gets it first, I'm going to give her a Flack attack because she already got a free problem set today. But if Grace gets it first, I'm going to give her a Flack attack. She already got a free problem set today. So that means if they get it first, you still have a chance to get a free problem set. Okay? All right, here we go. I'm going to erase, give you a lot of room to work with. It's going to be awesome.
Do we have to do it on paper?
Yeah, but that's not difficult, right? All right, here's example 1. I'm going to say it as I write it. You ready?
Yeah.
3x plus y plus x minus y equals what? All right, I'm going to check on you guys later. Not quite. Nice. Not quite. Not quite. That's right.
Oh, what if it's just?
It's a little weird. It's a new world. That's right.
Just.
Not quite. Sorry, I don't mean to like. It's just I enjoy your sound effects. Yep, that's it. Yep, that's it. Yep, that's it.
Can
Not
I
quite.
get it? Oh.
Okay, so here's what you could do. What'd you get? Yep, you did. So look what happens. You go to Starbucks and you say, I want 3 Americanos, 1 Frappuccino, 1 Americano minus a Frappuccino. What are you gonna have? Well, the Starbucks person is gonna say, so wait, you don't want any Frappuccinos? That's what they're gonna say. Maybe not like that, but in my experience, that's never. So you got a Frappuccino minus Frappuccino. These guys went bye-bye. They canceled each other out. So they changed their mind. They didn't want the Frappuccino. But you got 3 Americanos plus 1 more Americano. That's 4x. Okay? So who got it first? Dylan got it first. And then we got some other people who got it. Did you end up getting it? Addie?
Yeah.
Okay, just making sure.
Sorry, I can tell if you're looking at me or Marin.
Yeah, my eyes are a little weird right now. Hey, you got up to 155. Good job. All right. Dylan, you're at 106. Hunter, you got a point. Elijah, you got a point. Grady, you got a point. All right. Should we do one more?
I got a point.
Oh,
No.
well, yeah, I gave you a point.
Oh.
Maybe I didn't. I'll give it to you at 110. All right, you're at 110. Don't do any more because then you'll be at an 11 and that's uneven. Just kidding. You can do more if you want. Example 2, ready? Bonus round. 3x plus 2x squared plus 4 plus x squared minus x minus 1.
It's confusing.
Now careful, remember x squareds don't play with x's.
Oh, wait.
Remember math is very segregated.
Minus 1. I paper to write the whole thing. That's annoying. Anyway.
You ever wonder, or like, wait, did I just say that out loud?
No.
You don't have that filter?
Nope.
Not quite.
I think I got it.
All right, I'm coming. I'm coming. Nope. Ooh, I'm tricking all of you. Nope.
That's
Nope. I fooled you all. Good job. You're stopping at 55. You're pacing yourself. That's good.
I'm too smart.
Nope. Oh, I'm stumping all of you.
Oh. Ah! I keep seeing
Nope. You guys are overeager. You can't. You're combining things you shouldn't be combining.
I'm so confused. X.
So, how many different drinks are you ordering at Starbucks?
Why would you order like that?
You don't. You should combine like terms before you go into Starbucks because they're going to get really mad at you.
4.
And they can't handle that because they work at Starbucks.
Mine.
All right, what do you got? Say it out loud.
I just figured it out.
Nope. What do you got?
3. That X should be
Nope.
4.
What?
I'm so confused.
Impossible.
That would be 9.
Wait.
So, how many different drinks are there?
No, I think I got it. Maybe.
Nope. Why are you putting those together? That's gross.
Even to me?
You don't mix an Americano with a Frappuccino?
Grady.
Nope.
Wait, no, it's not over here. It's right here.
Nope. Oh my gosh, you guys are going to be so frustrated when I give you the answer.
Oh, I know. Honestly, I think
Yeah. Nope.
But that X is. Wait, I think I know it.
All right. I'm trusting you. No!
Seriously? Okay, I give up. I don't.
Don't ever give up.
Well, that
Follow
would
your
be
dream.
Well, doing the math problem was not quite my dream.
Nope.
4.
All right. I'm calling it. Time of death.
Wait.
1:36.
It sounded like a car alarm.
Calling. What was it? What'd you get?
I think it's an item.
No, it's not one term, guys. Because look what's happening.
What?
You go into Starbucks, and the only thing you combine this 3x with is this negative x right there.
Wait, that's negative? I thought it was
So
minus.
remember, these two are different. Remember we talked about that?
Wait, is that negative x?
Yep.
Thought it was-
Depends.
I could have sworn it was minus x.
That's what I thought. Wait,
It is,
I thought
it
that
is minus x.
It
You're right. Negative x and minus x, same thing. Okay, but go into
I just
Starbucks.
worded it weird.
Let's go to Starbucks together. So there are three Americanos
What are
plus
Americanos?
2. These are different.
Coffee.
So these are like caramel lattes. And then this is a different drink too, because this doesn't have any variables in it, right?
Oh,
So you
that's a
get
good drink.
4 waters
Well, that's boring.
plus 1 more caramel latte minus an Americano, because we decided we didn't want one, minus 1 of those waters. So what are we left with? So we've got 2x squared and x squared. That's 3x squared. What's 3x minus x? What's 3 Americanos minus Americano? Adeline?
It's 2. Sorry, my brain just blinked out.
2 Americanos. And then you've got the 4s. 4 minus 1 is 3. This is your answer. Isn't that crazy?
I knew
It
it.
doesn't feel like, and this is what it's going to feel like a lot in algebra, is it doesn't feel like I wanted a nice answer like 4. Or I think I saw a 5. Somebody put 5. I would love that. That would be great. But no, you don't want to pour all your drinks
Wait,
into
Mr.
one
Flack, I
cup.
found the answer.
That's
It's
disgusting.
3x squared plus 2x.
Good
plus
job. I get a free problem set.
I
Okay.
broke a pencil.
So, guys, don't be overeager. You cannot allow these guys to play with each other. It's very segregated. Okay? Math is not politically correct. Okay? You have to keep them only combine like terms together. Okay? All right, but you'll get a lot of practice with that when you do this. But that's all I got today. Good job.
Flack math. Give me some math and I'll give you some flack. Flack math.